Okay, here I want to talk about finding the area of composite figures or shapes, whatever. Area of composite figures. Composite figures are basically a mashup of a whole bunch of different shapes, right? So for example, if you did a simplistic ice cream cone, well, that actually is a composite figure, right? Made up of, if I put in an imaginary line there, I got a triangle here, and I would have to figure out what that perpendicular height is, and I got half of a circle there, right? Your composite shape might actually look even stranger. It could be part of a rectangle, and it has a triangle cut out of the side of it, right? Once again, it's made up of simple shapes. If I put in the imaginary line, we have a rectangle and we have a triangle. It could be a circle, and the circle has got a trapezium cut out of it. Maybe, right? We'd be given the perpendicular height there. We'd be given the radius of the circle, right? Whatever you do in terms of the questions of composite shapes, sometimes the trickiest thing is to actually determine what shapes are you dealing with, right? Take a shape like this, for example. If I have, like it's a garden plot, it looks a lot like that. I'm told that this side is equal to that side. I'm told that this side is equal to that side. I'm told that this side is equal to this side. And then I'm given just a bunch of measurements, like this one might be 9 centimeters, this one here is like 7 centimeters, this distance from here to there, that one will make that like 12 centimeters, and then this distance here, we're told, is like 15 centimeters, not drawn to scale, of course. You could easily get overwhelmed by that. All of these numbers and all of these different things that are written in there. But the honest truth is, it's actually quite simple. How many shapes do we see here? How many simple shapes? Well, the answer is there's only 2 simple shapes. We put in this imaginary line here. We have a large rectangle and we have a small rectangle. Right? The way that I would work this out, and I'll work this out so I can show you, is I would actually give each of these shapes a name. For example, the big rectangle, I'm going to call that A, shape A. For the little one, I'm going to call that shape B. Okay, so I have my 2 shapes. So I know that the total area of the bit that I want, this bit here, the shaded part, the total area of the shaded part will be equal to area of part A, that's the whole thing, minus the area of B, which is this cut out bit. So now all I got to do is a couple of very easy equations. I need to work out what the area of A is. I know that the formula for finding the area of a rectangle is length times width. I know that my length here is 15 multiplied by, well, now we have to do a little bit of thinking. This is, we don't have this side, but we know that it's the same length as this side. So we have to do 9 plus these 2 sections. What's the length of that section? Oh, well, we're given it here because it's the same length as that. So 7 plus 7 plus 9. So 14 plus 9, which is 23. So I would do that, and I would be able to actually figure that out. Here we go. We can have our 15 times 23 is equal to 345. And that's not complete. That has to be units squared, centimetres squared. I now need to do area B. Area B will be equal to this section, this small section. I have measurements for that. It'll be 12 centimetres by 7 centimetres. So length times width. Let me make some space for my paper. 12 by 3, which is 36 centimetres squared, right? Now if I go back to here, I know that I have to find my total area. It's equal to area A, that one, take away area B, that one. So if I now go total area equals 345 minus 36, 345 minus 36 is equal to 309 centimetres squared. And that is the total area of that composite shape. And it's not hard if you break it down into its individual parts.